Right, so today we're going to study square roots of a number. Okay, and first of all, let's understand the definition of square root. Okay, so if I here's the definition. Okay, if I have you know that, right? So this if both a and n are positive numbers. Okay, so a and let's use a b. Okay, a b are positive numbers. Okay, then if a equals b squared, okay, then you can write in the following way. You can say square root of a equals b. Just that's actually not inverse to each other. Think about this. Okay, so if you have a relationship, the two numbers are related by this. A is equal to b squared, and everybody understands that b squared is b times b, right? Then you can also express b in terms of a. Now, how to describe it? And you can use it. We use this notation square root. Okay, so let's see. This is kind of like a concept of inverse function. Okay, so 4 equals to square. Then that's equivalent to say you can say square 4 equals 2 or 2 equals square 4. Okay, right? So if you move to the square, to the left-hand side, then you change it to the square root. Okay. Of course, square root have another notation. It's like a power to the here's the notation. Square root a is also written a to the 1/2. That's another notation we're not going to talk about. The square root is a traditional notation. Okay. So clear, right? So that's the relationship. And you know what is a square A? Square A is going to be the number b whose square is equal to a. You can also read it like that, okay? Because b squared equals a. So square A is a number whose square is going to be equal to a, okay? And so that's the definition, okay? Now let's look at this relationship, okay? If I replace b by square root of a, right? Because b equals square root of a, so I put it into b. I put it into the formula on the left-hand side. You have this side, then great. Okay. Now, if I replace on the left-hand side, right-hand side, if I replace it by b squared, so I have this side then, right? Okay. Right. Clear? Yeah. So this a is replaced by b squared. Then square root of b squared equals a. So using now those are very important formula. Okay. So now use one of the formula, I can answer the question: what is square root of 9 squared? Square root of 9 squared equals 9. Right? You just needed to remove, that's a solid, remove 2. Okay. And also square root of 9 squared, right? Is also equal to 9. Okay. Yeah, based on about formulas. Okay. So whenever you see square root something square, then just remove the square. You get just put the original number there. Okay. So square root of 3, we don't know, but what is the value? Exact value, but it's a square. I know it's a square. So square root of 3 is the number whose square is going to be 3. That basically says that, right? Right. Now we also have to be very careful. Above statement is true only for non-negative numbers. Okay, it could be 0. Okay, square root of 0 by definition is 0. Okay, it's always 0. Okay, because a 0 square is 0. Okay, so that's it. So this formula, right? This above formula holds only for non-negative numbers. I should say, I changed the word here now, non-negative. Okay, including 0. Okay, this is always true. So that is the definition for the square root. Only that's defined for the non-negative number. Okay. Now we have to be very careful. Okay. So I have to say that the square root of what is our formula? Square root of b squared equals e only holds for only for, right? Only for non-negative number, right? Okay. So how about square root of -9 square? Square root of -9 square is not going to be -9. Okay, this is not going to be -9. The reason is I said that not the reason, but it's not guaranteed because we cannot apply about the formula to this problem. So what you should do is you do the square -9 square is going to be 9 square. So the answer is 29. Okay. So yeah. So then and it's it's yeah, -9 square. So when you want to remove the radical, and you also change the sign. So this is it. So let's do some estimate. Okay. So simplify this 49, not 49, 490,000. Okay. Simplify this one. We should know that 7 square equals 49. That's very important. So 100 square is 10,000, right? If we know that, then it's 700 square is going to be. So you can express as 700 square. Okay? Then use above formula, get 700. Okay? Yeah. But so let's simplify another one. You have a 2 to the power 6, 3 square, and a 5 to the 6. Okay. Now take a look at this. Well, if you take a look at this, yeah, first of all, you have to express as 2, right, cube square, and here's 3 square, and the 5 cube square. Okay. Then I want to express as some integer square. Then I can get rid of the square root. So I get 2 cube, 3, and 5 cube square. Now, this is a square root of some perfect square. And then inside that number is positive. So you can simply write. Yeah, you don't need to multiply them out at this moment. Yeah, this is good. All right, so this is good. All right. So our next problem is, let's consider, let's try to solve the equation. I'm trying to solve the equation x plus 1 equals 3. Okay. Now this is not a linear equation. Okay. It's not a linear equation at this moment. So how do we solve this problem? We're assuming, x plus 1 is positive. Okay. So the idea is that you square both sides in order to get rid of the radical. Okay. So here's the point. A equals B implies A square equals B square. Now, conversely, it may not be true. Okay? Yeah, be careful. Conversely, it may not be true. If A square equals B square doesn't mean A equals B. So when you solve the equation, this equation, A equals B, and you simplify, you square it, but when you are going to get more solutions. So at the end, you have to double check, okay? Now in this case, right? So x plus 1 equals 9, so x equals 8. I think this is the thing, we can double check. Yeah. All right, now I have to be careful when you square both sides, because if you look at this one, it's -3. Then if you square it, you're going to get a solution, still same solution. But at the very beginning, you already see that this has no solution. All right, so if you square it, you get solution. That means you get more solution because one solution is more than nothing, no solution, right? Okay, this is a good, just give you a simple example. Okay, the reason is the radical of any number, whatever it's defined, will be non-negative. Okay, so this is a remark. Okay, square root of any number is always non-negative whenever it's defined. Okay, b greater than 0. Okay, it's not going to be negative number. So when you say it's going to be negative, if it's defined, if b is negative, then it's not defined. Okay, we haven't defined yet. Define the square root of a negative number. Okay, okay. So square root of negative, and it is not defined yet. Okay, it's undefined. Okay, it's undefined. It's not a real number. Okay, so we're not going to start this. But now, so let's solve this question. X squared equals 27. Right. Well, according to above definition, so if x is positive, then x squared equals 27 is equivalent to say x equals 27. Okay, so that is solution. Of course, square root 27, is going to be, it's not a perfect square, so you just leave like that. Okay, you can simplify a little bit after later, but we cannot change. Okay, all right. So square root 27, this is a positive number. Okay? But we also know that negative square 27 square is 27 because it's square root 27 square is 27. So negative square 27 is also a solution, right? So x equals negative square 27 is also a solution. Okay. So in fact, the above equation has two solutions. Okay. So x squared equals 27 has two solutions. Okay. Plus minus 27. Okay. So when you solve equation, be careful. It's not always, unless you already know x is positive. Otherwise, you're going to have two solutions. Okay. All right, so take a look at the next problem. So given, I wanted to think about, given 7 times square 11, given this 2, okay, which one is larger? Okay. Which one is larger? Yeah, think about that. Okay, 7 times square 11 and 6 times square 15. Which one is larger? Okay, so so everybody says square root 6, square root, yeah, let's see. But we have to have a based on the following fact. Okay, so if A, B are both are positive, this is a fact. So A is greater than B if and only if A squared greater than B squared. Okay, those are two equations. Okay, so in order to compare those two numbers, we need to square. Right? Now, after you square, it's a 49 times 11, right? Times 11. So it's going to be 539. Okay. Another one, yeah. Once you go square, you get the integer. So this will be 36 times 15. So it's going to be 540. You can use calculator or do by hand. So which one is not? So clearly 7 square 11 is more than 6 square of 6 times square 15. So therefore, you conclude that 7 square 11 is less than 6. Okay, so you have to use this fact, the above fact. Okay, and if one number is larger than another number, then the square of that number is also larger than the square of the other number. Okay, and similarly, similar argument you can choose. Say it's also equivalent to square A greater than square B. Okay, so either way, so you can prove this. Yeah, this is but this is true only for non-negative numbers. Okay, for non-negative numbers. So we will. It's called a comparison of radicals. Okay. Right. Yeah, you choose yeah, they're very close. You know, when you square, they only differ by 1, right? So it's not easy to see at the very beginning. Okay, you cannot ask. Okay. Right. So if square n equals 9, right? What is n squared? Right. Well, what is n squared? You know, that this is a problem just trying to test you whether, some students were confused with the notation. Okay. With the definition of square root. Okay. Yeah. What is n squared? You see, Michael gave me wrong answer. Okay. So the square of n equals 9. If and only if, okay. If and only if, okay, what do you do? Yeah. You square both sides, right? So if and only if n equals 81, the n equals 81, that implies n squared is 81 squared. That is the correct answer. So the first two students give me wrong answer. Okay. So you have to write down, do the computation. Don't just think, oh, no. But maybe your brain makes mistakes when you put the definition of the square root. Okay. So that's why you jump to conclusion. N equals 81. N squared equals 81. Okay. N squared is equal to 81. So because you did not do the computation. Okay. Yeah, 81, right? 81, you have to do the computation, 81, right? Right? 81, right? 81 times 81. So that's going to be 6,561. That's a very big number. Okay. Yeah, it's a very big number. All right. Our next problem is explain why square root 2 is less than 1.5. Okay. Well, we're trying to estimate the square root 2 as much as possible. Now, square root of 2 is not going to be integer, clear, but we're trying to see how big of the number, okay? So to to estimate that, I just look at the square, okay? This is 2. And then 1.5 square is 2.25. And clearly, this is less than that, right? So therefore, square root of 2 is less than 1.5. So when you compare two numbers, even the number on the right-hand side is not a square root, then you just square both sides and compare. Without the square root, it's easy to understand, okay? So in mathematics, when we say numbers, it's not necessarily integer, okay? Numbers are two groups of numbers. So one is rational numbers, okay? And here, irrational numbers. Okay? Rational numbers can be always written as n over m, okay? Or if we express it in the decimal form, then it could be decimal number was repeating digits or was a terminating digits, okay? Yeah. Was a repeating digits or terminating digits, such like that 5.212121, and also, for example, 121.53. So those are the rational numbers, but they all can express as a fraction. Irrational numbers like square root 2, square root 3, square root 5, all of them, almost all of them are square root 6, square root 7, even square root 8. Those are the numbers, all irrational numbers, because you're not able to express them as the integers, integers over another integer. Okay, those are the integers over another. It can try to do proof. Early days people think square root 2 is a rational number, but then some mathematician that's a long time ago proved that square root 2 cannot be expressed as integer over another integer. Okay. So those are all the numbers. The reason all those most of the numbers, you can jump to the general conclusion. If the number b is not a, if the number b is not a, okay, if the number a is not a perfect square, then the square a in general is irrational. Okay, yeah, that's a fact actually. Okay. If a now negative is not a perfect square, then square root a is irrational. Irrational. Right? You cannot express. It's not that it cannot express as an integer over another integer, but you can approximate it, right? You can approximate. Approximation is very approximation. Yeah, it's very interesting. It's not easy to do, but yeah, we can let's do some approximation. Okay. Right. So our next problem our next problem is we're trying to estimate. Right. So if we already know it's between two numbers, okay, and n is integer. What is n? Okay, let's try and do this problem. Wow, square root 30, square root 50, and both are irrational numbers. They're both are irrational numbers. And we want to estimate. Okay, we want to estimate. Okay, we want to estimate. So So first of all, let's do rough estimating, okay? Do rough estimating. Yeah. N is integer, okay? N must be integer. So we know, you are told that the sum of the two numbers is between the two numbers, okay? So we have to do rough estimate, okay? So I know square root of 30 is less than square root of 36 and greater than square root of 25. So this side is 5, this side is 6. So square root of 30 is between those two numbers. Square root of 50 is greater than square root of 49, less than square root of 64. So 49 is 7, and this is going to be 8. Okay. So the sum of them is greater than, right, 12 and less than 14. No, it's not good enough. I have to, but possibly n is either going to be 12 or maybe 13. Who knows? But look at this. I think 50 is very close to 7. Square root of 30 is almost like a in the middle of a 5 and a 6. Okay. So my guess is n is going this number is very close to 12. More close to 12 than 14. Okay. So the reason is that you see square root of 50 is very close to 7 because it's very close. 50 is close to 49. So the sum, okay, the sum, I think my rough estimate is going to be 5.5 plus 7, slightly like 7.1. So this possibly is going to be 12.6, something like that, right? That's my rough estimate. So my guess, okay, I guess n equals 12, okay? So in other words, i.e. 1230 plus 1250 is less than 13. I have to find a way to prove it. Okay, you have to find a way to prove it. All right, so I double check. Okay, I double check is the square root of 30 is less than 50. 50 5.5 square. Okay, I want to see which number is big. Okay, I want to get F estimate on. Okay, so this is a true because 5.5 times 5.5 is going to be 30.25. Okay, you have to guess and try. Okay, and then is the 50 squares less than 7.1 square? And let's check the 1.1, the 7.1 times 7.1. That's going to be, 54.1. So that's great. So now you get the upper bound, square root of 30 plus square root of 50 is less than 5.5 plus 7.1. And indeed, this is going to be, it's a 12.6. It's not only less than 13, it's also less than 12.6. So finally, we conclude that, okay? Conclusion is it's given this, right? And the 13. So you get pretty good estimate. It's get pretty good estimate, right? Yeah. All right, let's do another estimating. Okay. Okay. So the next question is, how many integers can, okay, satisfy is between square root of 13 and square root of 131. Okay, so both are irrational numbers. Both are irrational numbers. Okay, I cannot scratch to estimate. Now maybe you can, there are a couple ways to do, right? Now, for this problem, there are two different ways to do. Yeah, there are two different ways to do. Yeah, you can think about, okay, do some estimate. So Michael, you give me the answer, but don't say you think, okay? You say, based on my computation. Have you done any computation? Okay. I think we can do, because these two numbers small, okay? In this particular case, if you want to solve this inequality, you just square it. So you just want to find the perfect squares between those two numbers, okay? Perfect squares, perfect squares, I know that the n squared should be equal to, 4 square, right? Then we get 16. 5 square, 6 square, 7 square, right? 8 square, 9 square, 10 square, 11 square, 12 square is 144 already, so that's stop here. So you list all of them, right? You list all of them. So there are 8 perfect square there between 13, because it's easy to handle perfect squares, right? So n is in 4, 5, all the way to 11. Total, right? Total you have 8. There are 8 integers there. Okay, clear? Yeah. Now you can also do rough estimate the square root of 13. Okay, because square root of 13, yeah, it's gonna be less than square root of 16, and greater than square root of 9. So square root of 13 is less than greater than 3, less than 4. Anyway, so you get this, right? You get this integer. Then square 131 less than square 104, greater than square of 121. So it's 11. So those are the two irrational numbers between those numbers. So then it's clear, right? If we draw the coordinate line, and this is the square, that's a 3, here's a 4, here's a square 13. And then this is going to be square 131. So here's a 12, here's 11. So you only consider integers, right? From 4 to 11, right? 4 through 11. Okay. So those are the integers, because this is the two numbers, right? The irrational number somewhere here, range between 3 and 4, as well as between 11. And I think this method maybe sometimes is better if we have to deal with larger numbers, right? Right. So for example, the next one, how many digits are in the square root of, I also tell you, perfect square. And this perfect square is 108868356. Okay, wow. So this is a perfect square, but it's not easy to find out what is this. Okay, it's not easy to quickly get the estimate. Okay, maybe I change, if I don't tell you the perfect square, I change the last digit from 6 to 5. Okay, then the answer is the same, because we only count the digits. Okay, we only count the digits. So I give you a perfect square just in case if you have a very powerful software, you can quickly get the perfect square. Okay. All right. So how do we estimate? Okay, we get we have to you see, count how many digits here already. Okay, count how many digits. 1, 2, 3. So in the total here, it's already 9 digits. Okay, 9 digits. Okay. Okay. And we notice that if you square this, okay, you're going to get 10 digits here, 10 zeros. Right? That's what we count, right? When you square it, you'll get double the zeros, right? 0 digits. So you have then you get total here 9. Let's see. Yeah. And then you do have yeah, 10. Yeah, double it. So this is a larger number, right? It's bigger than that number. Okay, it's bigger than number. Then I also cut off, right? So I just look at this, and then I have how many digits, right? I have 8, right? So 8. Okay, so 1, 2. Right. So now clearly, the number is between those two, right? So that means this perfect, I don't know its exact value. Right? This is definitely less than this square and greater than this square. Okay. Right. So when you're talking about square root, it's going to be between those two numbers. Okay. So if it's between those two numbers, then it's clearly, how many digits you are going to have, right? You're going to have 5 digits. I think it's 5 digits. Okay, so 5 digits. This is 5-digit number, right? Because it's greater than the smallest 5-digit number is, right, 10,000, 100,000. So this is, but never got to 100,000. So it's less than equal to 99999, right? So that's why it is a 5-digit, right? Right? It is a 5-digit number, 5 digits. Right? So it's a 5-digit number. The square root of that number is a 5-digit number. All right. Those are about basic estimate. How do we estimate? Because of irrational numbers, we do want to estimate that. Okay. And sometimes we want to know how many digits there are, and so on. Okay. So then I want to talk about some other formulas about the square root. So basic formula, there are 2 basic formulas we should have. One is for non-negative number, okay? I keep saying that for non-negative number. For non-negative numbers, A and B, okay? We have the following 2 identities. Square A times square B is going to square A times B. Another one is a square of A over B. Okay. Oh, I should write this. Yeah. Square of A over square of B should be square of A over. Okay. Those are the two important identity. Actually, we can prove that. All right. How do you prove the first one? Okay. How to prove that this is the first one, that's the second one. Proof of the first identity. You want to prove this this is true, right? So this sum and some number, I don't know what is that, the product of those two numbers. So when that's squared, okay, when that's squared, I get square of this and square of this. This is clear, right? If, you know, we're using the formula x times y squared is x squared y squared. This is the formula we already learned that before. Okay. But then by the definition of the square root of A, this is the A, the B. Okay. Square A and the square B. Okay, so that means yeah, simply just write A times B. So some number square equals, you know, A times B. And that number, right, is denoted by square root of A times B. Okay, right? Remember, if B square equals A, then B is the square of A. That's what we keep saying there, right? Those two are equivalent, right? So then you have this, okay? And then similarly, yeah, let's prove the second one, right? The second one, square of A over square of B, let's square, right? Then you square the numerator and you square the denominator, okay? Here we're using the formula x over y squared should be x squared squared. Then by the definition of square root, then get A, that's get a B. So that is the reason square A over square B is the square A over B. Okay. By using this, we are able to simplify some. We're able to simplify some radicals. Okay. For example, simplify square of 8. Okay. Simplifying square of 8, and that is going to be 8 is going to be 2 times 4. 4 is a perfect square, 8 is not. Okay, so that's going to be 2 times 2 squared. According to the above formula, I can separate it, right? And the second one is the square root of 2 squared. I know we have a formula, it's just equal to 2. So you can write as 2 times square root of 2 because traditionally integer should be right at first. Okay, so that is good. Then I slightly different, you know, simplifying 2 times 8. So that's two different ways to do it. I'm going to show you. And this is an easy problem. Okay, by the way, let's finish that first. All right, so this is going to be, you can use that formula directly. It's 2 times 8. That's going to be 16. Then 16 is a 4 square. So that's equal 4. Another way you can do is a square root of 2, but square root of 8 is a 2 square root of 2. So what you get is you have a 2 and you have a 2 square root of 2 square. So square root of 2 square is going to be 2. So that's why it's 4. It's the same answer, but different side, different approach. Right? It's a different approach. Right? And there are many problems like that. For example, I want you to do square 18 times square 50. Please do this. Simplify this. Okay. Can you do that? All right. So everybody got those answers, right? Okay. First of all, 18 is not perfect square. 50 is not perfect square. You can do this. Okay, 18 times 50. Okay. Then then you multiply this out, or you just simply write it 2 times 9 here and 2 times 25. 25 and the 9 both are perfect square. Then you get 2 square. 9 is a 3 square. 25 is a 5 square. So you got 2 times 3 times 5 square. That's 2 times 3 times 5. And you can write it 30. Okay, so 30 is the problem. And similarly, you can do the problem 36 over 28. This is at the very beginning, you get 2 terms, right? It's separate. Okay, but we can combine them, square root of 28. Okay, so there are a couple ways to do. Either you simplify the numerator and denominator. Okay, so 7 times 9 is 7 times 4, right? Right. So that would be square root of 7. Square root of 9 is going to be 3. That would be square root of 7. And square root of 4 is 2. But square root of 7 cancels out 3 for 2. You can simplify the numerator denominator first, then cancel the common fact. Or you can move them together first, then you simplify the inside. So 7 times 9, 7 times 4, cancel 7 inside. Okay, so you get 9 over 4 inside. Okay, 9 over 4 is going to be 3 over 2 squared. Okay, so then you get 2. So there are many different approaches to solve the same problem. Okay, now what I want to share with you is another important trick, and okay, a more important trick. So we are going to use it in many cases to simplify the expression. This is an important fact. Okay, so we know. Okay, see. We know x times y and x plus y. When you multiply this out, okay, you get x times x, or x squared. X times y is plus y, and y times x minus yx. Y times y minus square. Okay, but x times y times x cancel out, so you get x squared minus y squared. So that's why how to get x, right? Okay, great. And in order to get rid of radical, you always square, right? The square a square, is going to be a, right? So if I if I do this, right, replace x by square a, replace y by square b, then according to above formula, it's going to be square a square minus square b square, which is a minus b. This is a interesting. Okay, this is a very interesting identity. Okay, and sometimes the square b is already integer. It's possible. Okay. Okay. So let's simplify the following expression. Okay. So what I'm going to do here is going to be here's a square root 7 minus, okay, square root of 6. Okay. And on the top, square root of 7 plus square root of 6. Okay. Wow. I want to get expression without radicals in the denominator. Okay, without radicals in the denominator. How can I do that? Without the integral in the denominator, I needed to make it more complicated. I multiply the numerator and denominator by the same factor, but I change the sign. Okay. So what I should get? I get the denominator. I get a square root of 7 square minus square root of 6 square, right? But the numerator, I needed another formula because x plus y square equals x square plus 2xy plus y square. I hope you can derive this formula by yourself. I'm not going to do it. Okay. So you will get square root of 7 square plus twice of square root of 7 square 6 plus square root of 6 square. Okay. So let's simplify. The denominator is 7 minus 6. 1. Great. It's 7. 2. Square root of 7 plus times 6. 42. And the 6. So my final answer here will be 7 plus 6 is 13. So this fraction, very complicated fraction, can be changed to this form. Right? Can be changed to this form. All right. So now I wanted to work out this. Simplify square root 2 here. Right. And I put a square root 2. Okay. Simplify this so that there's no radical in the denominator. All right. Yeah. Well. Let's see. Anyone have given me an answer right now? I only get one answer. Okay. So let's do this. Okay. This is going to be you multiply the numerator, the denominator by the same number, right? Which is square root 2 plus 1. Then you get square root 2 square minus 1 square. Right? And here on the top is to multiply this, right? So the denominator is 2 minus 1. The numerator, square root 2 times square root 2 is 2. And the square root 2 times 1 is. So the answer is 2 plus. Aha. Yeah. 2 plus square root 2 is the correct answer. Okay. Now, we have to explain that square root of a squared plus b squared never equal to a plus b. Right? Yeah, this is yeah, it's never equal to a plus b. Okay, however, square root of a squared plus 2ab plus b squared is going to be square root of a plus b squared, and that's the ab. Okay, so which number is large if you compare? I think square root a squared plus b squared is less than a plus b, right? Of course, here a, b are positive, a, b are non-negative. Okay? A, b are positive, okay? Otherwise that's equal. Okay? So we assume that a, b are positive. So then you have that. The reason is this term is missing on the left-hand side. So that's why you get a smaller number, right? You get a smaller number. Okay? You get a smaller number. So they're not equal. You know, the common mistake students make is yeah. Another important identity. You can use the example to check, right? But I already proved that why they're not equal. Another one is square of a times square plus square of b. That is not equal to this. Now, which one is large? Which one is large? Okay, but which one is large? Okay. Yeah, the one on the left hand side is large. You know why? Because you squared. Okay, you compare, right? You compare, you know, do comparison. Square of a plus b squared is going to be a plus b. But this side, when you square it, is with square of a squared plus twice of square a plus, right? Square b squared. And then you have a plus 2 square a square b and plus b. You already have a plus b here. So clearly, this is going to be larger than, you know, square of a plus b squared, right? So that means square of a plus square of b is greater than square of a. Okay. So you can see that, okay? So we don't have much time left. I covered the whole chapter today, actually. It's a little bit very fast, but those are all the material, you know, we need to learn. So the very last one I want to discuss is the following problem, okay? Simplify square of 50 minus square of 18 minus square of 8. It's possible, okay? So let's do it. Neither of them is integer. No term is integer. Maybe they will be cancelled out. Okay. Square of 50 is going to be 2 times 25. 50, right? Here's a 2 times 9. Here's a 2 times 4. Okay. All of them can be simplified, each of them. So 25 is going to be 5, right? Square of 9 is going to be 3. Sorry, 2. Right? It's going to be, yeah, square of 2 times 3, because square of 9 is going to be 3. And here, square of 4 is going to be 2. So now you will see you have a 5 square of 2 minus 3 square of 2 minus 2 square of 2. So the answer is 0. So this complicated expression turns out to be just equal to 0. Okay, so those are all the problems, and I'm not going to ask you to do all the exercise in the back side of the book at the end of the chapter, but I will select some of them. I wish you to complete. Maybe your parents ask you to do more. That's their choice. Right?